For this one, uh, we have a function which is twice the set of all twice differentiable functions which are concave up for all x from -1 to 1, and from for any function f in this set, let xf be the number of points for which fx equals to x. Okay, so let's move on to the options. For a option, there exists a function such that fx equals to x has no solution. That means there exists a function which lies entirely above this line in this interval. So obviously we can take a function high up, say 1000 e to the power of x. So this function satisfies our this function belongs to S, and obviously it has no solution from -1 to 1, because at 0, at less than 0, this is greater than 0, and the line is below the x-axis, and at 0 this is 1000 and it will grow faster from this. So yeah, we have a function such that xf equals 0 for that function. So A is correct. B, for every function we have xf less than equals to 2. So for that, what we'll do is we'll define gx equals to fx minus x. Now that will give us g double prime x equals to f double prime x. Notice that gx is clearly differentiable and double differentiable in fact, and its double derivative would be equal to f double prime x, which is greater than 0. So if xf is greater than 2, then gx has more than 2 solutions in the given interval, which will mean g prime x has at least 2 solutions, which will g prime x equals to 0 has at least 2 solutions, which will give that g double prime x equals to 0 has at least one solution, which uh, contradicts the fact that g double prime x is strictly greater than 0. So that means that xf should be less than or equals to 2. So B is also correct. Then for C option, the function fx equals to x to the power of 4 satisfies this condition. So x to the power 4 equals to x implies x into x cube minus 1 equals to 0. So in this interval -1 to 1, it has 2 solutions, 0 and okay. So not x to the power of 4, but let's say x to the power of 4 by 8. So this will have 2 solutions. So x to the power 4 by 8 minus x gives us x into x cube. So not this, but this. So this gives us the solution as half and 0. So it has 2 solutions. So C is also correct. And D is incorrect, because the function, it satisfies our, it belongs to S, and e to the power of x minus 1 at x equals to 0 is 0, and otherwise the derivative is e to the power of x. So the function is strictly increasing. This function is strictly increasing. Okay. Uh, no, this won't really work. So what we need is a function which is tangent to this line. So x to the power 4 won't do. E to the power of x, e to the power of x minus 1, say x. So this is true for x equals to 0. Will it have any other solution? So e to the power x minus 1, we need this. So the derivative of this function is e to the power of x minus 1. So that means the function is decreasing when x is less than 0 and increasing after that. So that means the minima will be at x equals to 0. It would be the minima. So yeah, this indeed has only one solution at x equals to 0. So fx equals to e to the power of x minus 1 will satisfy the condition. So D is incorrect. So why does it satisfy this condition? Because x equals to 0 is the root. Then we will check gx equals to this, and then we will notice that g prime x is equals to e to the power x minus 1, which is less than 0 for x less than 0 and greater than 0 for x greater than 0. So before 0 the function is decreasing, and after 0 the function is increasing. So there's the minima at x equals to 0 and the minima is equals to 0. So the function is strictly positive. That is e to the power of x minus 1 is greater than x for all x other than 0. So yeah, it only has one solution. So answer is A, B, C.